Welcome to the sixth video in our series, Understanding Inflation and Escalation in Defense Acquisition, Best Practices for Cost Analysis. In this video, we will move past our guide for better public understanding and onto a guide for best practices in cost analysis. If you need more of an introduction, we suggest watching our beginner series guide in Understanding Inflation and Escalation in Defense Acquisition, a guide for better public understanding. Today, we will present a general framework for approaching one method for escalation analysis. Let's get started. To begin, let's re-examine how we calculate an escalation rate. Let's say over time we observe that a program cost $100. Then, after another period of time, the program cost $105. Clearly, we observe the program increasing in price, but what was the escalation rate? As you recall, we calculate escalation by putting the final observed price over the initial observed price. In this case, it would be $105 on the numerator and $100 as the denominator. This will result in 1.05. After subtracting 1 from the equation, we can show the result as a percentage. In this case, the escalation for the program was 5%. In our calculations, the lowercase e is used to represent escalation rate. In addition to escalation, we use symbols to represent other terms in our calculation. For inflation, we use the symbol of pi. Price, we use the uppercase letter P, and for real price change, we use the letter R. However, it's important to note that real price change can be expressed in two different ways. An uppercase R represents real price change in dollar terms, and a lowercase r represents real price change as a percentage or rate. Recall our approximation of real price change from video 4. Now we will show you the formulas which are used to actually calculate real price change. We will calculate the real price change for item J at time t. As we explained, real price change is simply removing the effects of inflation from the price. To begin, we will use the price of item J at time t as the numerator, and we will place 1 plus inflation as the denominator. Next, we'll take all of this and subtract the price for item J at the previous time. This formula will give us the dollar amount of real price change. However, we are more interested in the rate of real price change. To get the rate of real price change, we will use the exact same equation as escalation, except we remove 1 plus the inflation rate to isolate the real price change that occurred between the two time periods. Let's rearrange this equation to better show the relationships between escalation, inflation, and real price change. Our first step is to isolate the price of J at time t, which is in the numerator of the equation. To start, we'll want to add 1 to both sides of the equation, which will give us 1 plus the rate of the real price change of J at time t on the left side of the equation. Next, we'll want to multiply the denominator to each side of the equation. This should give us the product of 1 plus the rate of the real price change of J at time t times 1 plus the inflation rate times the price for item J at a previous time. If we flip-flop the equation so that our isolated variable, the price of J at time t, is on the left, we will get the adjusted equation, which is displayed as equation number 2. Next, we will want to divide the price for item J at a previous time to each side of the equation. This will leave us with the product of 1 plus the inflation rate times 1 plus the rate of the real price change of J at time t. If we distribute and multiply these factors together, we will be left with an extra positive 1 in the product. We can take this 1 and subtract it from each side of the equation, so that we are given the price of J at time t over the price of item J at a previous time minus 1, which is equivalent to the inflation rate plus the rate of the real price change of J at time t plus the product of the inflation rate and the rate of the real price change of J at time t. As we can see, this is equivalent to our equation for escalation in equation number 3. Using our result, we can show which portion of the equation we used in video 4 to approximate real price change. But notice that there's this interaction term we omitted. This accounts for inflation on the value of real price change. In our beginner's guide, we learned that the cost of escalation built into an estimate contains 2 components, inflation and real price change. Inflation affects all prices in the same proportion, while real price change is the portion of escalation unexplained by inflation. Since we are analysts, we want to consider all the ways in which the real price can change. We can break these changes down into 3 different categories: specific market prices, contractor business effects, and government effects. Let's begin by discussing specific market prices. While inflation affects all prices in the same proportion, an individual item within an industry or commodity market may experience average price changes completely separate from inflation. For example, notice how the price change for apples appears to be completely unrelated to the price change for submarines. This is because they sit in 2 different commodity markets. Luckily, professionally developed price indexes are available to track the price changes in many specific markets. For example, if you're trying to estimate the cost of a submarine program, the different aspects of the program have their own unique indexes, such as the steel required to build the submarine, or the labor required to construct the submarine. Even the submarine itself has its own specific market price index. In addition to associating with an industry or commodity market, items produced by one or more particular firms may exhibit price changes not representative of the industry average. These are referred to as contractor business effects. Contractor business effects may include costs such as healthcare needs of a labor force, and specifically for the DoD, hiring contractors from the limited pool of cleared professionals. Other important business effects that cannot be explained by industry trends alone include geographic region, unions, process improvements, and many others. In addition, the government can have substantial effects on year-to-year price fluctuations. These are called government effects. For example, when the government changes the amount of units it plans to purchase for a program, costs can change due to volume-related effects. Additionally, the government may have other requirements, such as information reporting and business regulations. The government may even pass legislation that can affect the cost of a program. However, government effects do not include changes to quality, such as new or more advanced components, as directed by the government. Now that we have all the pieces that go into escalation, we can combine this information into a chart that shows all the contributors to escalation. There can be many factors that contribute to escalation that is observed on a unit price, such as the variables we have already discussed, and also including the economy itself, which includes factors such as changes to the unemployment rate, wages, salary, and other factors such as foreign supply chains. Cost estimates should incorporate the escalation rates that best forecast funding requirements for the system being estimated, taking specific markets into account. Cost analysts and the organization publishing estimates are responsible for determining which escalation assumptions are appropriate and where they are applicable. Thank you for watching. This concludes Video 6 in our series, Understanding Inflation and Escalation in Defense Acquisition, Best Practices for Cost Analysis. For more information or additional resources on how inflation and escalation are used in defense acquisition, please visit our website at cade.osd.mil/policy/inflation.